So,
Guys, good show.
all right, high five, high five. I will say two things. First, you guys couldn't see this because it happened behind the scenes, but our plan was we're trying to do comments out
there.
on the observation lounge because we have this incredible observation lounge. It would be silly not to do comments out there.
Right.
Speaking of, I'm going to work my way out there. However, so what we did is we asked Mike.
No, do I just stay here?
No, we're going to all move out there.
We're all going to move out there?
We asked Mike.
Open before you
Oh.
Ha, ha.
We asked Mike to rotate his cameras because he was going to answer that one question. And then, unfortunately, the interview went really long and Jared had to leave. So we lost Jared, so we had to bring comments back in here. And I walk in here and Mike is sideways. I'm like, tell him to turn his camera back around.
We're like, do the thing.
So we're scrambling. He's scrambling to get it set back up, like moments
And he's
before
like,
we come back.
this? We're like, yeah, huh?
But he didn't get like any context whatsoever. We're just like, turn your camera back. So thank you for making that happen. That was awesome. The second thing.
No problem.
I
had
think.
no idea that Jared had left. So,
During
the commercial, I get a message from Dutta.
Neither did I.
Oh no, crap.
Yeah, he's like, oh, we have to reset this. I go, no, we lost Jared. Just do the thing. It's okay.
Yeah. The second thing is, I just wanted to say your news segment, Mike.
The commercial crew updates.
The crazy long one that everyone was really worried about.
By the way, I said, don't worry. He only has one sentence in between. He's got a bunch of images.
Yep.
That was magical. It was
fantastic job.
It was
Effing-tastic.
fast, straight to the point.
So good.
And you were like images with everything. That is what I want. Oh my God! Probably my favorite news story we've ever had on the show. It was awesome, and I just wanted to congratulate you for that and thank you because it was remarkable and I loved it. And I even said in the chat room,
very much.
"Oh my God, this is awesome! I love this."
Yep.
It was like I was watching my baby. I was like, "This is amazing! It's amazing!" So
He basically said that news story was better than our marriage.
yeah, that's basically what I just said. Are we gonna just?
Yep, silence is the right answer. Okay, fantastic. Can we do an open?
I don't like it when mommy and daddy fight.
Oh yeah. No, that's amazing. We need to do an open. So apparently, I can guess what Mike's gonna do for his open.
Yeah, you're gonna have to take one. of
Launches
Jared.
and stuff. Yeah.
We're gonna have to.
We're gonna have to.
We've
fudge it a
lost
little
Jared,
bit.
so
I know.
I'm wondering.
Oh crap.
I mean, I can say we've got launches.
I could just do them all from the observation lounge.
I mean, yeah. However you want to do it.
Yeah, because if you
So
do-
like, you're bringing in the show by yourself and being just like, today we have a very special episode for you guys or something like that. And do the rundown, and then when it edits, it'll cut right back to me, Carrie, and Jared in the newsroom. So maybe it'll make sense. A lot of pressure on you, though.
I don't feel like that flow works.
it's also going to be weird if Jared's voice isn't in it, and then all of a sudden he appears on screen.
Yeah, I agree. We can't do it from here. I think I have to do it out there, and I think I should do it solo. I think I should say, I'll say coming up, we've got launches, we've got.
We've always got launches.
I know, that's a good point.
Got launches, got a bunch
here.
of
We've
we got
got,
commercial crew updates,
coming up,
and a lot of
coming up, an
pictures.
update on commercial crew. French. Coming up, update on commercial. Let's see here.
Images of a black hole around the horizon.
Coming up, black hole images, commercial crew updates, and an incredible interview with an incredible interview about Cassini. All right, that works.
And a lot of Cassini.
Sure.
Sounds good.
Why do we continue to do opens?
Soft opens?
Yeah.
I don't know. I feel like it's a good. That's a valid question. I feel like it's a good way to get into the show, give you an idea as to what's coming up before you commit 2 hours to it, because that's what this one's going to
Sure,
be.
but I mean it's also in the description of the video, is it not?
Kinda.
I don't know. I still watch Westworld regardless of what I think is going to happen that day.
I don't know. I feel like All right, internet. Do we think we don't need a cold open for this one, or do we like the cold open?
Maybe,
And now I have to wait.
That's a debate for later.
Well, it might be a debate for later, or it might be the perfect time to try it out anyway.
Yeah.
I mean, we do have
what I
the
mean?
open built into the thing.
Right.
Yeah, they like the opens. I don't know. Feel like it brings cohesion to the show. We're gonna try it.
Okay.
It starts the show on the foot.
It does. It gives the.
I understand. I'm just trying to give you
No,
options.
it's a good question. I appreciate it. I just.
Okay, you're
I
gonna have to
think
tell
we
them
need
to
do it.
shush,
Yeah.
because they think they're done now.
We're interrupting your show here.
Oh, we're in After Dark. There's no interrupting.
Get one more. They're so cute.
Okay, now you have to ask her the 5 questions because.
Yeah, we do have. So our interview went so much longer than normal that we did not ask you our normal 5 questions, and I would like to get to that. But before I do that, I need to do an open.
Okay, so Shelley, you need me to put this back on?
Yeah, if you don't mind. All right. Ready? This is number 1. Number 1. Coming up, images of a black hole, a commercial crew update, and an incredible interview talking about Cassini. Stay tuned. Tomorrow begins right now.
One more you broke.
Oh, I broke up?
Yeah.
Yeah, I think I just got.
That was me though. I had you. You're on Carrie Ann's channel, so your EQ's all weird, so I had you boosted.
I understand. That makes sense. I'll drop this here. I feel like. Ready? You good? All right, this is number 2. Let's do this here so I can see it. Number 2. Number 2. Coming up, incredible holes. Tomorrow begins right now.
That's a whole different show.
Number 3. Coming up, incredible images of a black hole, updates on commercial crew, and I have an interview with Lisa.
That was so Ron Burgundy, it's not even funny.
Was it really Ron Burgundy?
Yeah. The facial
Clings to life.
the facial expressions, your dramatic pause and everything.
Well, the pause is for the
I know
image.
you need it, but you don't start with the facial expressions when you start speaking again.
They're covered. It's covered.
Blah, blah, blah,
It's
blah,
covered.
blah,
But
blah,
there's a
blah,
covering
blah,
shot,
blah,
Dada.
blah.
There's a covering shot. You know why it's called a covering shot? Because it covers me up. Number 4. God. Coming up, images from a black hole, commercial crew updates, and I have an incredible interview with Lisa Tatchke. That's Lisa Tatchke. Tadji.
Ignore the T. It goes to Tadji.
And I have an incredible interview with Lisa Tadji about Cassini. Stay tuned. Tomorrow begins right now. See what I did there? I have an edit point because you know what? I have a covering
That's all
shot.
you. That's all you.
I have a covering
That's all
shot.
You. I don't
Sounded
care.
good.
We're going to do number 5 just in case because I don't trust my editing capabilities. All right. Coming up, images from a black hole, commercial crew update, and I have an incredible interview with Lisa Tadji. We'll take take 4. I don't want to do this anymore. Come back in on set. I got it during the interview. It was fine. When I have to do the freaking open.
Back on?
Yeah, you're good.
I can't hear me, so
I can't hear. Yeah. I have the added advantage of the earbud.
this is true. Yes.
All right. I think that might be the longest interview we've had.
Wow.
It was great from start to finish. Just incredible content. Thank you again for just some.
I love just sitting around yakking. So it's
It was pretty awesome.
yeah.
If you don't mind, a little bit more time. We do have some more questions in the chat room. I'd love to get some of them answered.
Sure.
All right. But let's start off first with our general questions.
Okay.
The first is Moon or Mars first.
Oh.
I don't pull my punches.
Yeah, I
These are
know.
serious questions.
I think I would rather go to Mars first.
Would you go?
For me. If I could come back, yes. Yeah. To go and to stay, it would be nice to at least come back and visit. It's like, yeah, don't want to be there
Bit of a
full
journey.
time.
Bit of a
Yes.
journey to go. Like
Yes.
you stay for a week and be like, that was awesome, and then you come back. It's like 5 years out of your life, or no, I
Yeah.
suppose that'd only be. You gotta wait for orbital mechanics.
Yep.
When do you think humans will first land on Mars?
Well, let's see. Current estimates.
No, when do you
See
think?
if we'll manage. I'm just hoping that it happens before I retire, which is in 2026.
All right.
So I would like to see that happen before 2026.
When do you think humans will set foot on the moon again?
I think that's probably more likely, short term. Probably in the next 5 to 10 would be my guess.
And last question.
Yep.
Why space?
Why space? Because it's there. I mean, the possibilities, as you think about people in general, and you think, why do you want to go across that mountain range? Why do you want to go look there? When you grab a telescope, and we were just yakking about that, when you grab a telescope and you see the moon or you see Saturn for the first time in a telescope, all you want to do is go there and find out what it's like. So it's a desire to just do. It's because it's there.
Can you imagine going to Enceladus and like setting up base camp and just kind of hanging on Enceladus? Although it'd be
it's really
it'd be cold and really wet apparently. Like you just be constantly covered.
Yeah, you probably have to clean the windows off regularly.
But you'd have such an amazing view.
Oh yeah, among other things. But it's also you're thinking, well, okay, there's no atmosphere to speak of, so you have to make sure that you're, think lunar type if you're going to do that. It's got
I think that's assumed with any non-Earth. Yeah.
Well, I mean, you got atmosphere at Titan, but that don't mean you can breathe it.
Well, that's my point. Is you're bringing
Exactly.
your life support with you.
Exactly.
Ideally long term kind of stuff.
Yeah.
All right, let's see here. Let me go back into the chat room. Mini Stoge has the best comment for the room, which is "Never retire, Lisa," in all caps.
I will try. I do enjoy what I do.
And Space M says you should write a book.
That's the first time that's ever come up. I write stuff all the time, but it's usually very humorous in nature, not strictly work related. But then I have an awful lot of friends that have done so already, so I'll think about it.
Let me back up here. Let's see here. I got to go back to the. Let's see here. Yeah. So I'm just going to start. These are going to be totally random, and here's the problem: is that they were asking questions relevant based on what you were saying at the time.
Okay, so we're going to
and
have
now
to
we
backtrack.
have no context.
Okay.
For what we were talking
Okay.
about, so this is going to be super weird. Just so you know.
We
All
can
right.
do this.
All right. So.
We can task switch.
The first one is fairly easy. Destructor1701 says, "My goodness, Cassini alone has been so incredible. I can't imagine how amazing a fleet of them would have been."
To think that we could have potentially sent up 4 or 6 different missions. The whole idea with that was to try to do in-depth studies at a specific location and to have a structure that allowed you to take a lot of instrumentation with you. So that you really had the opportunity to look at stuff in detail. And Earl Mays, our project director, said something because somebody had asked him a question at an interview a couple of weeks ago. And he said they would ask him about what was the one thing that we did right or that we can pass on to future missions. And he said that you do a flagship mission like this and you put the right instrumentation on it because you don't know what you're going to find when you get there. Mm-hmm. And so you build yourself broad.
Sure.
So that you can have a lot of stuff. Cassini's got instrumentation that covers from the UV to the IR and the visible range in between, and they all overlap so that we have some corroborating information on the wavelengths, and then you have the radar that comes in over the top of that. So when you can build something that's like that, I mean, imagine what we could have found if we'd have had a whole bunch of these.
Are things changing now, though? So I'm getting away. So because we've got these small sats, and we were talking last week about new propulsion for small sats that could actually do some pretty incredible things.
Yeah, they can.
You don't need to build these ginormous spacecraft
This
anymore,
is very true.
with the exception of things like radio communications.
Right.
That still requires
radio and propulsion because you need the fuel. And that's always something where, I mean, we didn't necessarily, let's say you're already there. If all you're going to do is move a little teeny satellite around, you don't need a huge tank of something, but you're going to need something to control it for a long time. The mission, this particular one, when it was designed, and we're talking originally in the early 80s was when they started to come up with the concept for this. The idea was to be there for a long enough period of time to be able to really understand the Saturnian system in detail. And this was what we could build at the time.
Mm-hmm.
So yes, stuff is getting smaller. And look at the Juno mission. There's not as much stuff on it as there was on Galileo as far as instrumentation.
Mm-hmm.
But it is, some of the pictures that are coming back from that, I mean, if you've seen them, they're
Mm-hmm.
absolutely stunning. And we're learning an awful lot. And the spacecraft is much smaller, which allowed us to put these enormous solar panels on that one.
Yeah, that's an understatement. Yep.
To be able to handle the power at that distance. And we still can't do that out at Saturn's distance. The technology's quite there, and we've got so little sunlight compared to Jupiter out there. I think somebody, years ago, somebody told me that the solar panels would have to be the size of tennis courts to run this. I heard another rumor that said something the size of football fields to be able to handle it. I don't know which is correct, but it would have been prohibitive to try to have done this via solar panels. But the fact that we could do something in a much smaller scale and get a lot of really good science data is the direction we're heading. We have to go that way. Launch costs a lot. I mean, what are you going to do? You have to make your spacecraft smaller, ultimately.
Which ties to the next question quite well from Sage, which is the scale of these spacecraft always defies all convention for me. I think it's really hard for people to relate to rockets and spacecrafts and their scales. We can't fathom how, like, the human brain is just not very good at understanding any of this stuff, really, like the grandiosity of all of it. Like,
right.
They're just, I mean, can you put into context about how big this is?
School bus.
School bus. So you launched a school bus and you sent it to Saturn.
Yes. Yeah.
And all the children were safe.
Yeah, they did not have the instruments looking out the windows instead.
At the California Science Center.
Galileo was quite large too. We have a full-scale mock-up at JPL at this time of the Galileo spacecraft. They had to knock out the ceiling to be able to make room for the antenna to be able to put it on display. And the magnetometer boom it sits with enough space around it so that you can walk, but it takes up most of the rest of the room over your head. You've got the mag boom. And they're huge, and you don't realize that. And Cassini was bigger than Galileo. Cassini is the biggest one that we ever sent into the outer solar system.
And Dutto was trying to mention
at the California Science Center, I believe there's a 100% scale model.
Yeah, there's a one, and remember, Lisa can't hear you.
Right.
There's a 1-to-1 scale model at the California Science Center.
Yes, if the one in Los Angeles, and if you're going, I would spend the day and go and see Endeavour, which I actually got to see before they shipped it. I was very, very fortunate. I happened to be in Florida at the right time and managed to get to go to the vertical assembly building, inside the vertical assembly building, right after they had stopped the shuttle program. It was literally the first day they were taking tours in. And we had taken some friends, and there were a whole bunch of us that had gone, and so we got to go in to see this. And they're in there in the process of stripping all of the stuff off of Endeavour that would have been dangerous to have on display.
Sure.
But here it is. I'm sitting there, I turn around, and here's the nose Endeavour sitting literally 75 feet away from me, and I was just in shock. So I'm dying to go see it on display because I've not been to the Science Center in a very long time.
I'm going to air quote on display.
Yeah.
Because it's not actually full in its full configuration yet, right?
Not yet.
It's just wheel stopped, which
Yes.
is it's still very cool and very impressive.
Yes.
But I think seeing
Well, the new display that they're planning is going to be quite cool.
Yeah, it's going to be amazing with it
Yeah.
with it fully vertical in
Yes.
launch position.
Yeah.
It's certainly very cool, but there's something, at least for me, my brain breaks when, like, you see these rockets horizontal, you see the shuttle horizontal,
Yeah.
and you're like, oh yeah, that's pretty big. And then you take that exact same object and make it go
But it's
vertical.
this way? I know.
Yeah, and then something in my brain goes, and I'm like, oh my, it's so huge now. It's the same size it was when it was horizontal, but now,
Yeah. Well, they if you go to the Kennedy Space Center. Thank
Yep.
you. I knew it had come to me. If you go to the Kennedy Space Center, they have a rocket garden in there, and
yeah.
you can see some of the shorter ones.
Yep.
But it's nothing, even when you walk in order to get the scale on the Saturn V, for instance, which is immense, it blows your mind. They actually have it inside now, and they still have it lying down, but they have it indoors if you haven't been in many years. And you can walk down and you just stand off to one side and just look down the height of it as you look down. That's the first time you get some semblance of the scale. And that's even with the gaps. You realize even if you close the gaps, you're like, dang, that is really
But the
huge.
gaps,
Yeah.
the gaps would have been. I mean, if that is distance. That distance is correct. They didn't add distance. I believe they just took those parts out.
Right.
Yeah, basically the fairings.
so that you can see it,
because the interstages.
Because the cool stuff is looking
Yeah,
at
yeah.
at the rocket motors.
Exactly.
Because all of that was hand welded.
Yes.
Yeah.
Yes, and all the rivets and
Yep.
oh yeah, oh
Yep.
man,
That was a piece of artwork in and of itself.
and the
But-
wiring, yeah.
But back to where we were.
Yeah.
If you're going to go to the California Science Center, if you go one direction, I'm told you can go and see Endeavour. If you go the other way, you can see the other models and mock-ups that are on display, and one of them happens to be the full-scale Cassini. There's a half-scale at the laboratory, which takes up quite a bit of room,
I'm
actually, in the von Karman Auditorium, named after Theodore von Karman. And there's also a full-scale Voyager in there. So if you get a chance to go, I highly recommend taking a tour through the auditorium and the museum, because you get at least 3 full-size spacecraft in there. But if you want to see the Cassini, we just didn't have a place to put it. It was too big, and we were thinking, we already had to cut the hole out to put the Galileo in. So what are we going to do with this one? And so we wound up sending it to the Science Center, and they have hung it from the ceiling, and you can walk under it on the first floor, and then you get up on the second floor, and you can walk around the second bit of it. So it actually hangs between floors, and it's actually quite incredible to look at. And I need to go back and look at it again, because I forget. When you haven't seen the full size for a while, you forget. But I actually won a bet one time with a friend of mine. She's one of our scientists, and I adore her to pieces. She's one of the smartest people I know. But I got her one day. We were at open house, and I will show you one here. Here we go, right here. That is a reaction wheel.
Sure.
We have 3 of them around the edge, and then one of them is up top someplace.
Just to help
Where
keep
is
the
it?
vehicle stabilized.
Yeah, because it's 3-axis stabilized. Oh, here it is. It's on the back side over there. I did have it right. We had the quarter scale model, right, out for open house, and we were sitting there, and she turned around and looked at me, and she said, "What's that?" I said, "It's a reaction wheel." She said, "No, it's not. I said, "It's a reaction wheel." She said, "No, that can't be the reaction wheel." I said, "Trust me, that's the reaction wheel." I turned around and looked at one of the attitude control ones. "Hey, Letitia, what's that?" She goes, because she said, "Oh, I bet you $10 that's not the reaction wheel." I said, "Letitia, what's that?" She goes, "Reaction wheel." I went, "I gotcha." Yeah. So it was, but it's hard when you look at something that's the wrong scale, because things don't look in proportion, and,
Sure.
and suddenly you forget what was that? Wait a minute, what was that? This or was that? You can't tell anymore.
Yep.
Yeah.
That's the other hard part when you have a lot of large objects next to each other. You
Yes.
also
You
lose
lose
the
scale.
ability of going, right? It's just everything's so big that everything just looks small again,
Yep.
because your brain tries to compensate for it.
Yeah.
This one comes from LBCG. Got a few really good comments on this show, which is, I think meant to say, is it the Juno mission which is coming after Cassini, and did you work on it? Although Juno and Cassini, they're 2 different planetary objects.
Yes,
going
they're
to
2 different ones. So Juno's at Jupiter, and
Yep.
it is there now, and it has been since for several months now. I think we're close to a year. I'm trying to remember when they got there. I sort of lose track sometimes. But they have been getting some absolutely stunning pictures of Jupiter. Some of the most amazing images of the clouds and the storms, and the colors are just absolutely amazing. And if you're looking for that, you can go to the JPL, the Jet Propulsion Laboratory, jpl.nasa.gov, and look up under missions, and you can find current Juno, and they'll have all of their current images online if you want to see them. because they're getting some really good data back.
And they're
Yeah.
allowing mere mortals to manipulate the data and come up with really great images as well on JunoCam.
Yeah, right. It's a fun mission. I didn't work on that one specifically. I got a lot of friends that did.
They seem similar-ish.
In some
but-
ways, yes. Yeah.
I was going to say in that they're studying different planets in our solar system.
Right.
I assume they have similar but different payloads on them.
Yeah, much smaller on Juno, and I'd have to check exactly what their instrument complement is.
Is that just because it can be smaller, because the technology allowed it to be smaller?
Well, sometimes it's a matter of how you budgeted your spacecraft. I mean, Cassini was budgeted as a flagship mission, which has a certain dollar amount attached to it with
Higher
regard to
dollar
budgets.
amount. Yep.
Yeah. And then as you go down, you get less and less, and the Discovery missions are the lower end. And I don't remember off the top of my head. Trina would kill me. I should know this. Where Juno fell as far as the funding was concerned. But part of that will determine how big the spacecraft is. And how many instruments are on board, because you not only have to pay for the instrument to get built, you have to pay somebody to be able to know how to run it and operate it on the ground. Because when we build sequences and stuff for the spacecraft, now the Cassini is a little different because it's older, but we build 10-week sequences for Cassini. So we've got what we call a background sequence. It's just a set of commands. Mostly it's when you turn away from Earth, take this science data. And when you turn back to Earth, this is what time you turn back, this is what telemetry mode you need to be sending us data at, and this is where you ought to be pointing, right? So it knows where to be. And that's the bulk of the background sequence. And then there's other things that'll happen in and around that, but we do 10-week sequence at a shot. But it doesn't store stuff on board the same way that a computer does now. My background is software engineering, that's where I started. But when you look at some of the newer missions, like the Mars missions, they're actually flying something that is almost off the shelf. I mean, it's been modified, but it's almost an off the shelf kind of operating system where you actually have files. And it stores stuff as a file, and you play stuff back as a file, whereas Cassini is a little older school and a little more in line with Galileo and the missions before it. When you start with Pathfinder forward, that's when you see the transition in the way that the spacecraft are built. But you still have to have somebody sitting there saying, I need to take a picture of that. That means these commands have to go out to the instrument to do this, and we have to have this happen at this time and this happen at this time. So there's still somebody that has to be around to know how the instrument behaves, and you usually specialize in one or the other. For a while, I worked with the radar folks on Cassini, and I worked on an instrument for the Phoenix lander, the Mecha one that did the wet chemistry. And so we had a whole group of folks that were working on that, and it was their job just to command our instrument. So you have a group of folks that have to do that. So there's a certain amount involved with that. So you have to keep that in line when you start to budget your stuff, your spacecraft, how much you think you're going to do it, how many people are you going to need. It all plays into your top dollar.
How about collaboration? From the chat room, Jack asks, what was it like collaborating with the European Space Agency on the Huygens probe, right? Huygens
Yeah,
probe.
Huygens. That was one of the most amazing collaborations, because we didn't even see the Huygens probe until we got to Florida. When you see that picture that we had where the spacecraft's in the chamber, that was a thermal mass that we had on there so that we could correctly model the thermal properties of the probe with respect to the orbiter. But we didn't actually join up with the Huygens probe until we got to Kennedy Space Center, and then we mounted the real one on the side of the spacecraft. But we constantly talking back and forth. Okay, what's the interface look like? Okay, we need to do this. Well, this is what our command set looks like. This is what we're going to do, and how are we going to do the relay on the data once we start to do the probe mission, and we're getting the data from the top of the atmosphere, which is about when we started gathering data for them. and this is what we're going to do with it, and how much time have we got, and how long is the battery going to last? All of those questions got answered with everybody just conversing. And we did have somebody here in California that was working with the Europeans. It was the go-between. And that was their job, to make sure that everything got coordinated properly. But it all worked out really, really well. We got some amazing data off that Titan mission. You know, they had three parachutes on that thing? 3 parachutes. Heat shield, right?
Yep.
So it hits the atmosphere first, and then they had one. It was kind of a chute to pull out the next one.
Like a drogue.
Right, and it had a really ginormous parachute on it, and that was so that it fell down really slowly.
Sure.
During Titan's atmosphere, because the atmospheric scientists wanted to get as much data as they could at layers to find out what was going on at different altitudes inside of it. But then if we'd have left it at that, on that parachute, we would have never made it to the ground before the orbiter was out of range to receive data. So they changed to a smaller parachute, and it sunk down to the ground on the smaller parachute. And that's why we managed to get to the ground a little faster. Huh. Isn't that cool? Stuff you learn when you're listening to Dave Duty.
But you didn't run them all at the, so you would run the drogue, and then you'd run the second one, and then you'd let that go and run the third one in sequence to change its speed on its
way down.
That's pretty cool.
Yeah, and we didn't know whether we were going to land in water or land on solid surface, so they built the probe so that it would float for a bit if it landed on liquid, and then if it landed on solid, it would last a little bit longer. We actually did last longer than we anticipated. It lasted at least 4 hours before it froze.
The next one comes from Lur. Is there a follow-up mission to follow Cassini once it's ended?
At this point in time, no, although I believe there are a number of people that are in the process of trying to propose new missions. You got a lot of folks that really want to go back to Enceladus.
That whole system seems like an inspiring, incredible system. Right?
And of course, if you're going to do Enceladus, and you'd be in the region anyway. But my guess is when we go back, it will probably be more focused than something the grand scale of Cassini. That they'll sit there and go, these are our science targets, and then they will pick
closer
the
to a discovery mission.
Yeah, so they will pick something a little bit smaller. It would not be as large. Next large-scale mission, I heard somebody saying they would really like to go to Uranus. We got a lot of interesting things going on at Uranus. And did you see there was a news broadcast? Apparently the guys on the ground knew that they had a solar prominence. It was headed for Uranus, and they got the Hubble Space Telescope to watch it when it hit it.
Oh no, I missed
and
that.
they actually saw some disturbances in the upper atmosphere.
That's pretty.
I thought that was really cool. I went, that's great. Nobody's talked about Uranus in years. And I was really pleased, because that's
Northern Lights going on kind of thing.
Yeah, that's exactly what was happening. And I've always liked Uranus just because that's the first bit of the Voyager mission where I was on lab to watch the data come back. And I wasn't an employee at the time. I was there as a guest of another person, and the ring scientists had said, well, we believe we should have rings there. We know we found rings at Jupiter. We know Saturn's got them. We believe that there should be some at Uranus. And so we were sitting down watching the data return. I was in a conference room in a building, and was watching the data come back, and this blank screen comes up. And my friend that invited me, he goes, I think that was supposed to be a ring image. It was blank. And I went, oh, well, that's interesting. Didn't think too much of it. And he goes, well, we'll see what happens when they post-process it. A little while later, the post-processed image come up, very distinct. Boom, here's that ring arc sitting there on that image. And I heard the ring scientists down the hallway just jumping for joy and screaming and yelling, like you see us on TV when something cool happens. And I sat there and went, I want to work here. That was the first point when I sat there and went, I want to work here. Because that was cool. That inspiration, that, wow, look what we found. And look, our hypothesis, it can be proven. I mean, those are the things that inspire you to get up in the morning and go to work.
That's a really cool moment to have. Yeah. Like, oh, hey, we found rings on a planet.
Yeah.
Yeah, that's.
Yeah, we
like,
proved
I
it.
want to do that.
Exactly. I had no idea how I was going to wind up doing it. I really thought I was going to be a scientist to begin with, and I wound up getting into engineering instead.
This question comes from our own Space Mike, which is any risk of the radioactive generator exploding or causing a chain reaction when Cassini enters the atmosphere?
No. There's not any oxygen there. You need oxygen to burn.
This one comes from Johnny Spacer, which is, what was the most interesting discovery made by Cassini, in your opinion?
Well, I've got one just because I like the moon, and then I got another one just because, hands down, everybody's just going, it's the nutso thing. Enceladus has got to be the top. The stuff that we're finding there is absolutely fantastic. Titan takes a close second, I think. For me, there's one other one, and most people don't know anything about it, but it's one of those things that was proposed prior to us getting there, and we actually did figure out what it was. And that was the yin-yang is the correct term, that's on Iapetus, which, first of all, I just like saying it, Iapetus. It's a cool moon. It's my favorite, actually. They've always known that something weird was going on. When they watched it, they used to watch it, and you'd get sunlight, and then it would disappear. Yeah, there it is. And you would get sunlight, and then you would see it on the other side, and it wouldn't be there. And then you'd go the other, and you'd see it again, and then it would disappear, and you wouldn't see it come out the other side, right? Because it's kind of like, what doesn't make any sense? And then you get it gets brighter and brighter and brighter as it goes around. Well, as you can see from that image there, it's really dark, 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 and the albedo is very, very dark where it's dark, and it's very, very bright where it's bright. Mm-hmm. And it turns out it's got this kind of organic sludge material that it picked up when it's in orbit on the leading edge because it is tidally locked. Mm-hmm. So it always has the same face towards Saturn. So when it goes through, you get a little bit of both. So you get a little bit of light, not a lot. When you go over to the side, you're looking at the back end, and the back end's nice and bright, and you see it bright, and it disappears. And I'm like, where did it go? It's really dark when it comes out the other side. Completely explained. Now we know why it's there, which I found cool. Not to mention the fact it looks like a giant super ball that was stuck together. That ridge that runs down the middle. I remember seeing the first pictures of that, and I thought, that's exceptionally cool. It looks like a giant rubber ball.
It does.
Yeah.
It's like something you play with
Yeah.
in Target.
Exactly. Except I think the craters would make it go a little wonkly.
This one comes from Marty Scher. I believe that's how you say that, which is, what is your favorite picture Cassini took?
I think I had that up, was the Saturn picture with the blue on the northern hemisphere. That's one of them. No, I'm looking at the...
Is it that one?
Keep going. That one. That one right there. The combination of the colors on that, I think, the little bit of artist that I have in me, really finds the color palette in that very pleasing to look at. And it's not that it got us a whole lot of science or anything. It was just one of the prettiest things I had ever seen. I thought that's gorgeous. Yeah.
I think it shows this grand scale of this planet with this super thin and petite ring, which is still quite huge, but it shows kind of the...
Compare the size of that moon to Earth.
Can you compare the size of the moon to Earth?
You mean that little one?
Yeah.
Well, it's going to be smaller than Earth significantly because you're going to put 762...
What about the size of our moon?
Dione, I think Dione's probably closer to moon size, maybe a little smaller.
So it's about the size of our moon.
Yeah, I would think so. I know that one of the science guys is going to come in and says, "What's the matter with you? You don't know how big that is."
But I mean, still, even if you're to put Earth on that ring, it still wouldn't be a huge orb in that.
No, it wouldn't. Do you have the picture of the hexagon? Do we have? Did it make? No, that's the South Pole. Yeah, that's the. Wow. Did we miss the?
Let's see.
The one with just the hexagon on it? Yeah, okay, it's possible. The whole hexagon is 2 Earths wide. And this is a portion of that, so I think it's, well, Well, that might work. You can sort of use it because the storm on the southern pole is similar in size, although on the northern hemisphere it's got the hexagon. But you see where it sort of turns blue?
Yeah.
Down to the bottom, that's about the width. And between that and you can see where the center of the storm is. And so you got 2 Earths between that and the other side of the blue section around there, width. So if that helps.
A little bit.
Size-wise,
It's
yeah.
hard. It's hard. All
It
these
is.
things
It
are
is
really
very hard. Well, if you think about Earth, Saturn and its rings, it'll fit between Earth and the Moon with a little bit of space to spare. That's the main ring system, not including the E ring.
It'd be really cool to have a ring system around Earth. It'd be pretty.
Yeah.
It's called space debris.
Carrie Ann said
That's
we
more
have
of
what
an
is called
orb,
space
though.
debris. Yeah.
Yeah, it's a large flying bat of gnats, right?
So this question.
That's it. That's the one. That is 2 Earths across. So it'll give you an idea of how big the hurricane in the middle is. It's quite small compared to, it'd fit on the Earth.
It's still hard. It's still hard to have context between
Yeah.
that and like the previous image because it
I
gives
know.
you an idea of how large
know.
Saturn is. Almost said Jupiter. Saturn is to Earth, but
Yeah.
not like
Yeah.
how large Earth would be.
Dione is,
balancing on the
if I
rings.
remember correctly, Dione is smaller than our moon a bit. But you probably see our moon hanging out there. It'd be kind of cool.
So here's a question from Destructor 1701, which is, I read an article a while back about gravimetric data that suggested there's an asymmetrical structure off-center within Saturn. Any comment on that? Kind of feel like a tinfoil hat enthusiast asking that. But interesting because we can't really see
Yeah.
into Saturn. It's a gas giant. So
We know something weird's going on. One of the things that we did notice was that we have what they call kilometric radiation. I hope I got the right term. We noticed that when we went to Jupiter that we could use that radiation to determine the orbital period of Jupiter so that we knew how fast it was rotating underneath the clouds. And they thought, well, we'll use that when we get to Saturn. You got to Saturn. Does not seem to have anything to do with the rotation period with regard to the planet. So yeah, you wind up with this, and it actually changed. That's the weird thing. It changed based on whether we were at the northern summer or southern summer. So you got these 2 lines of radio signals, and then they crossed in the middle, and they went over as we went from winter to summer in the northern hemisphere. But now, what was the question again? Because that particular one, I'm not sure I can answer.
saying that there may be some asymmetrical
Yeah.
structure within Saturn that's off its center.
Who knows?
And
Yeah.
now, when he's saying structure, I don't think he means.
But-
He doesn't mean building. He means
Right,
like
right.
there's some sort of mass within the planet
Right.
that we can't see.
Well, they're hoping to get a little more of that data with the grand finale, actually. When we go through that section, we get a little different view of the magnetic field during that time period. And as I recall, that is one of the things that they're trying to do. They're trying to figure out what the internal structure actually is. Because there's been debates over the years about whether the center is actually solid down at some level. You've got some little pea-sized something or other in the middle of it.
Cheese.
Yeah. Or if it's all basically gaseous or liquid going down that far. So whether I can answer that right now, I don't know, but hang on a few months and maybe we'll have some data for you.
All right.
Yeah.
Lance asks, how do you think the E-ring will evolve over time?
That's a good question. I'm not even sure if the scientists know. It's very diffuse right now, so you don't know if it's going to coalesce or spread out even more, although it seems to be mostly in one location. But I would have to ask a ring scientist to get a good answer on that one. They're the experts by far.
I actually had never heard the term ring scientist before. I think it's really
Yeah.
cool that we have scientists that what they do is study planetary rings.
I learned so much just sitting around and talking with a few folks getting prepped for this because being an engineer, there are times when you just sit there and the science goes, all right, wait a minute, explain that to me again. they've learned so much just about the main ring system, that we already saw, that we've already been watching in the visible throughout the course of this mission, and they have written volumes of papers on how the rings are structured and how long they think they've been there. But we'll get a better idea once we get the mass numbers after we start proximals.
Jason519 asks, if we launched an equivalent mission today, what improvements would the current generation of technology provide? So you get the same budget, you get the same premier class mission, you're still going to Saturn, but you get to use modern day technology. That's the only difference.
Wow.
What changes?
Resolution.
Sure.
More than anything else, I think you're going to change resolution.
Does your bandwidth change at all, or is that just still a limitation
that would
of the radio?
too. That would as well. One of the Mars missions, I can't remember which one. It was launched somewhere in the last 5 to 10 years. It's one of the orbiters, and it has an enormous data rate. So high, in fact, that in its main mission, it was expected to return more data than all previous missions combined. So, and that was all previous, planetary missions. The volume that we can get, maybe we're almost there with the laser.
Yeah, they're testing
laser
that at the space
communication.
station.
That might be a nice thing to add if we could use it at that distance. I don't know, because you have to have the beam has to.
Photons want to spread.
Yeah, just a bit. Yeah. So anybody that wants a lightsaber, it's a little difficult. Although I read something somewhere, somebody figured out a way to make it stop somewhere, which was a big thing, and I'm like, what did you do? I know.
I'm hereby officially declaring shenanigans on that.
Yeah, I know. That seemed a bit odd to me too. But yeah, I think the communications would be the higher the data volume, and then higher resolution for the different instruments. And when you start talking about some of the basic subsystems, I think we'd probably try to get a different type of reaction wheels, because we had a bit of problems with those over the course of the mission. And maybe do some, let's see, what else have we lost? We lost caps. That had a short in it, and we had to turn it off, the instrument. We lost that several years ago, much to the dismay of the scientists, and rightly so. I'm trying to think what else would we want to do. Oh, the computers would be smaller. We could use a different operating system. Oh, there's all kinds of stuff.
Right, it'd be faster, I assume. You get those you get the 166 megahertz power PC processors. I think those are the fastest ones rated for space.
Oh yeah, this thing's running at
30 megapixel cameras.
That was huge at the time when we were writing software. 1 megahertz. Oh wow.
All right, I'm getting people saying that we're out of time. So I'll end with this last one from Minnie Stoge, which I think is a really great question, which is, how do other people get to where you're at today? How do people who are inspired by this follow that dream and do something cool with planetary science or whatever?
I kind of was at an odd time when I came into to this line of work, and I sort of fell into it. And I do mean that, literally fell into it. This was not anywhere what I anticipated doing. I had a friend that was in a youth group at the laboratory, and when I started in college, he says, "You like this science stuff? Why don't you start and be a member of the team?" And I started showing up all the time, and I got to watch all the scientists all the time. So that was one. When I started at college, I wanted to do, I thought I wanted to do astronomy. I found it fascinating, always had. Yeah. But they didn't have astronomy at Cal Poly Pomona. They don't have a major for that, so I was taking physics and geology, because if you're going to study planetary bodies, you need both. And I didn't know which direction I was going to go, so I thought I'd take both. A couple of years down the line, physics and I parted company, and I was looking for something else to do, and realized that I had a knack for computers because I'd taken it as a general education requirement. And so I started taking classes in programming. And I was trying to get, everybody wants this. They always want to have the biggest toolbox ever. And I was trying to learn every single language that was possible out there at the time. That way I was the most marketable individual. You could put me any place and it wouldn't matter.
Mm-hmm.
I had trouble getting into some of the classes that I wanted to get into. One of them was C class at the time. It was offered, and I kept trying to get in. It was always, it's full, it's full, it's full, it's full. So I wound up taking ADA, which is something that at the time was the precursor to what they call object-oriented programming now, right? And I had taken the class at the time because I thought, well, okay, I can take that one, I'll take that one. But I needed to get a job for the summer. So I made a comment to somebody that was in the group, and one of the advisors said, what would you do if you worked here? And I said, I'd empty trash cans. I meant it. I wouldn't care.
Mm-hmm.
I'm working at JPL.
Sure.
I don't care. I'm actually there. And he said, get me your resume. And I said, okay. And I walked away and I went, I don't have a resume. I need to write a resume. So I went out and I got my resume together, and I had mentioned on there, I said, I'm taking an ADA course, I'll finish it in June. And I got a phone call, and they said, you were the only one that knew basically how to spell it, let alone how to code in it for summer hire. And I said, okay. And so I got hired for summer hire work because I knew this odd language, and they were using it for a research and development project at the time. So I had done that, and once that was ending, I was getting out of college. And so I'm like, oh, I need a job. Let me start asking around. And somebody said, you know ADA, don't you? And I said, yeah. They said, Cassini's going to use ADA. Why don't you put your application in over there? And I got hired. And it's just like, okay, I'm here for life now. I'm this, you know, I don't expect to leave JPL until I'm dragged away, I think. I enjoy it too much. But for somebody who's trying to do it now, something like that is not as easy. So when you're looking to get in, the lab gets at least 20 applications for every position that's available. So you have to really make sure that your resume is top notch. If you're really interested in getting a job at the lab and you have a specific thing that you want to do, make sure you keep your grades up. Do the best you can. Make sure that you have other things that you do, because just like getting into college, it is the personal interactions are just as important. Being able to work with somebody else in a room. So it's, okay, you're not the lone wolf over here doing things. You're willing to walk down the hall and ask somebody a question, because that collaboration becomes exceptionally important when you're dealing with something as big as these spacecraft. And make sure that as soon as you can, try to get in for an internship. Apply for an internship. When you're in college, even if you don't get in the first year, do it, start immediately. Start when you're a freshman, just say, this is what I want to do, let me see if I can get a job. And try to get in on one of our internship programs, because you do actual work. For one, it's not make work. We are told, don't do that, don't have them over there filing stuff. They need to do real work. And I did. When I was working as a summer hire, I was writing maintenance routines. I was writing a database program. I was helping to do throughput studies. So I was not just hanging around. It's like, oh, it's just the kid in the corner, have her file the paperwork. I was actually doing real work. And so that's the reason that you kind of want to get into the lab, because they actually give you something solid to do. And once you do that, if you do a good job and you're there and you get along with people, they will hire you back. And so once it's almost like get your foot in the door, and then you can stick around hopefully for as long as you'd like. Yeah.
It's pretty awesome.
Yeah.
All right, Lisa, that is our time. Thank you, everyone, so much for watching. I hope you
Appreciate
guys
it.
had fun. Like I said, we'll be back next week with Mike Mealing. And I don't think I mentioned, but Tomorrow Cities is on a monthly schedule. So sometime next month is when we'll have our next Cities episode. And then later this year, we're working on Tomorrow Science as well. So that should be a lot of fun. Thank you, everyone, so much for watching. See you next week.